This is 1.4. We're talking about radical equations. So we're talking about how to isolate a radical, how to solve a radical by eliminating the radical, how to solve an equation where the exponent is a fraction or where the exponent is higher than x squared. Let's get started. All right, so these are examples of radical equations. The most important thing to remember with radical equations is that if you have more than one solution, one of the solutions might not satisfy the original equation or might be extraneous, okay? It doesn't mean you made a mistake. You followed the correct math steps, but the answer doesn't solve your problem. So very important to check your answer if your equation began with a radical. Put your answer back in to check that it's not an extraneous answer. Extraneous answers you just wouldn't include in the solution. So a radical equation, the variable is underneath the radical. So we need to do something to make that radical go away, right? Let's talk about inverse operations. Multiplication and division are inverse operations. Addition and subtraction are inverse operations. And then when it comes to a square, the square root is the inverse operation of the square operation. So if you're taking a term and raising it to the third power, the third root of that term would be the inverse of that term. Good? And it continues forever. So the fourth root would be the inverse of x to the fourth power. Good? So for the example, here we have a radicand of 1 minus 2x. Notice that the minus 1 is not part of the radicand. So that is separate. And that our index is a 3, not a 2. Here it's a 2, because if there's no number here, it's an understood 2. You assume it's a 2. But here, they give you the number. So that's a third. We're taking the third root of 1 minus 2x. Good? Okay. To solve the radical equation, the first step is to isolate the radical. This radical is not isolated. When they say the radical, they mean the radicand. So you're isolating the radicand. Good? Isolate it, then eliminate it, then solve. Always checking your answer after you solve it. The third root of 1 minus 2x minus 1 is 0. Isolate the radical means we're going to move this negative 1 to the other side of the equal sign. What's the opposite of minus 1? It's plus 1. So I'll add 1 to both sides. Third root of 1 minus 2x is equal to 1. Good. So we've isolated it. The next step is eliminate the radical. How do we eliminate? Just like we eliminated subtraction by adding, we're going to eliminate the third root by taking this same term to the third power. Anything I do to this side, of course, I have to do to this side. Good. This eliminates this, so now we just have 1 minus 2x on this side. Here, 1 to the third power is just 1, or 1 times 1 times 1, which is 1. Good? Now, it looks like every other equation we have solved in 1.1 and 1.2. We're just going to subtract 1, because that's a positive 1. 1 minus 1 becomes 0, so negative 2x equals 0. Divide by negative 2. 0 divided by anything, not counting 0, is 0. Okay? Remember, you have to check your equations in this in this lesson. So, is the third root of 1 minus 2 times 0 minus 1 equal to 0? 1 minus 0 is 1. So the third root of 1 minus 1 is 0. The third root of 1 is 1. 1 minus 1 is 0. That's true. Check your answers. Next, we have the second root, or the square root of 12 minus 2x is equal to x minus 2. We have already isolated the radical because 12 and negative 2x are both under the radical. X minus 2 are both on the other side of the equal sign. Good? So we've isolated it. Now we're going to, step 2, eliminate it. To eliminate it, just like we did over here, we're going to raise it to the second power because that's a second root. Anything you do to this side, you have to do to the, anything you do to the left side, I should say, you have to do to the right side, right? Those just cancel. That cancels that, and you have 12 minus 2x. Here you have x minus 2 squared, or x minus 2 times x minus 2, right? You're welcome to use the equation a squared plus, or sorry, minus 2ab plus b squared at the end, or you can just use the FOIL method. So it's 12 minus 2x is equal to, when we FOIL it, it's x squared minus 2x minus 2x plus 4, right? 12 minus 2x equals x squared minus 4x plus 4. Now you are just going to put this into standard form or combine the like terms, right? See what you're left with once the negative 2x and the negative 4x are on the same side and combined. You also just want to remember that you want anything that you do have into standard form, so it's fine to move both the 12 and the negative 2x over to the right side. Make sure that your leading term is positive. So that's a positive x squared, so I'm going to move the 12, put that under the 4. And in the same move, if you would like, you can move that negative 2x by adding 2x to both sides. Now we've successfully eliminated the 12 and eliminated the negative 2, so now we just have 0 is positive x squared. That's what we wanted to keep a positive. Negative 4 plus 2 is a negative 2x. 4 minus 12 is negative 8. And now you're just looking at a more traditional looking quadratic equation, right? So for this quadratic equation, you're just going to factor it if you can. You're welcome to use the quadratic formula, whatever your favorite system for solving these is. I'm thinking I might be able to just factor it kind of in my head, right? So x squared can only be x times x. I want something that multiplies to negative 8 but adds to negative 2. What are my factors of a negative 8? I have negative 2, positive 4, positive 2, negative 4, skipped 1, sorry, negative 1, positive 8, positive 1, negative 8. Are there any others? Or do any of those add to negative 2? That doesn't add to negative 2, that doesn't add to negative 2. This adds to negative 2, right? So we can say it's x minus 4, x plus 2, or x plus 2, x minus 4, doesn't matter the order. And now we're back to the same thing we were working with 1.2, is a times b equals 0, then a is equal to 0, or b is equal to 0. Either way, solve for x. You get x is 4, and over here we get x is negative 2. Good? Difference between this and 1.2 is you need to check that these are not extraneous, okay? Our original was the square root of 12 minus 2x is equal to x minus 2. I'm going to replace the 4. The square root of 12 minus 2 times 4 is equal to 4 minus 2. So 12 minus 2 times 4, 2 times 4 is 8, 12 minus 8 is 4, right? So the square root of 4 is equal to 4 minus 2 is 2. So that one's okay, that one's not extraneous, so that's a good answer. Sorry, couldn't see what I was writing. And then for our second one, same exact thing, but I'm going to use a negative 2. So it was the square root of 12 minus 2x equals x minus 2. And I'm going to use a negative 2 this time. The square root of 12 minus 2 times negative 2 is equal to negative 2 minus 2. Negative 2 minus 2 is a negative 4. 12 minus 2 times a negative 2, or negative 2 times a negative 2 is 12 plus 4, right? The square root, 12 plus 4 is 16. The square root of 16 is equal to negative 4. Is that true or not true? That's 4 is equal to negative 4. That's not true. So we're going to say that that is not a solution. That's an extraneous solution. The only real solution for this one is x equals 4. X equals 0 for our first one. X equals 4 for our second one. We checked this answer, we checked this answer, we checked x equals negative 2. X equals negative 2 did not give us an answer that worked. Third example is the square root of 2x plus 3 minus the square root of x plus 1 is equal to 1. All right, I've just paused the video and checked our My Math Lab. There's not really a question like this on your homework, and it would take a very long time to solve this. So instead, I'm going to replace it with 4 times the square root of x minus 4 is equal to x. Okay, so we're ignoring this one. And instead, 4 times the square root of x minus 4 is equal to x. So now you have an x on both sides, notice, okay? Don't worry about it, just notice it. Again, we want to isolate the radical and then eliminate the radical. This radical is not isolated. This radical is in fact being multiplied by 4. I want to isolate it. The inverse of multiplying by 4 is dividing by 4. So I'm going to take all of this side, divide it by 4. Anything I do to this side, to the left side, I have to do to the right side. So those eliminate. I'm left with the square root of x minus 4 is equal to x over 4. Good. Next step is eliminate the radical. You do it the same way we've been eliminating the radical in all the other examples. It's the square root of x minus 4, so we're going to raise it to the second power. Anything you do to the left side, do to the right side. Now we're just left with x minus 4 is equal to, distribute that squared. So x squared over 4 squared, or 16, right? Okay, now what I would do is I would multiply by 16 because I don't like fractions. That cancels that. I just have an x squared over here, a positive x squared. 16 times the x is 16x. 16 times a negative 4 is a negative 64. Good. Now I want to put it into standard form. My x squared is positive already, so I'm going to move the 64, and I'm going to move the 16x. So I'm going to subtract 16x from both sides, add 64 to both sides. Good. That was just a nothing. That was me starting to write a plus when I wanted to write a minus sign. So now I have 0 equals x squared minus 16x plus 64. Is that okay? So from 4 times the quantity square root of x minus 4 equals x, I am now at 0 equals x squared minus 16x plus 64. Now you're just going to treat it like any other factoring problem or any other quadratic equation. If you like using the quadratic formula, you can use the quadratic formula. If you like using the square root method, you can use the square root method. Well, no, you can't. You could complete the square. Anyway, all right, let's just factor it, shall we? So we want a number that will multiply to equal 64 and add to equal a negative 16, right? So 64 is a perfect square. It's 8 times 8, right? Will 8 and 8 add to negative 16? It will if it is a negative 8 times a negative 8, right? So that becomes x minus 8, or x minus 8 squared. Yeah? Still equals 0. Sorry, I changed the side. X minus 8 equals 0. X will equal 8. You can put it back up into your original equation. 4 times the square root of 8 minus 4 is equal to 8. 8 minus 4 is 4, so that becomes 4 times the square root of 4 is equal to 8. The square root of 4 is 2, so that becomes 4 times 2 is 8, and that is true. So the answer is going to be x equals 8. Good? All right. Now we are looking at situations where we have one variable and it's being raised to a power, but it's not the first power and it's not the second power, it's the power of a fraction. What does that mean? What it means is we translate that fraction into a radical. So the rule is x to the power of m divided by n is equal to that same base. So here's our base. The n, let's start with the m. The m, the top number, is our exponent. And then that bottom number becomes our root. Okay, so you take what you have to the power of 1 over 2. That means the 1 is your exponent under the radical, and your 2 is your root. So 3x minus 5 here is the base. Sorry, let's read it. It's 3x minus 5 raised to the power of 1/2 is equal to 2. Obviously, the 2 stays the same, but 3x minus 5 to the power of 1/2, 3x minus 5 is the base. It's being raised to the power of 1, right? M is 1. And then the index of our radical is the number 2. So our x here was 3x minus 5. Our m here was 1. And our n here was 2. So we put the 1 there, we put the 2 there, and we kept the base the same. So here's our base. Our exponent, the top of the fraction becomes the exponent, the bottom of the fraction becomes the index. All right? Now we're just going to solve. So to rewrite that, you don't really need the 1, so I'm just going to rewrite it. You don't need the 2 either because it's an understood 2, right? So we're just saying the square root of 3x minus 5 is equal to 2. Treat it just like we treated those first 2 examples. Were there 2 or 3? There were 3 because I kind of added one right at the end, right? So the square root of 3x minus 5 is equal to 2. We have isolated the radical. Now let's get rid of the radical or eliminate it. It's being squared, so we're going to raise it to the second power. Anything I do to the left, I have to do to the right. Those cancel, and I just get 3x minus 5 is equal to 2 squared is 4. Good. Add 5. Add 5. 3x is equal to 9. Divide by 3. Divide by 3. X is equal to 3. Good. Make sure it works. 3 times 3 minus 5 to the power of 1/2 is equal to 2. 3 times 3 is 9. 9 minus 5 to the power of 1/2 is equal to 2. 9 minus 5 is 4. 4 to the power of 1/2 is equal to 2. And if we look at what that means 4 to the first power and then take the square root of it. So the square root of 4 to the first power is 2. 4 to the power of 1/2 is 2. It's true. Okay, our next one is 2x plus 1 raised to the power of 1/3. So if we think about this again, our x, looking at this, is 2x plus 1. Our m is again the number 1, so it's just raised to the first power. And our n, or our denominator, is 3. So we're taking the third root of 2x plus 1 to the first power is equal to -1. I'm going to rewrite that as the third root of 2x plus 1, without that 1, is equal to -1. So without that exponent sign. Now it's isolated. We're just going to get rid of the radical. Here we're taking the third root, so I need to raise it to the third power. Anything I do to the left, I'm going to do to the right. That eliminates that, and I get 2x plus 1 is equal to -1 to the third. -1 raised to the third power is a -1. Two x plus 1 is a -1. Let's just solve for x now. So we'll subtract 1. 2x equals -2. Divide by 2. X is -1. Plug that back in, make sure it works. 2 times -1 plus 1, all raised to the power of 1/3, should equal -1. So 2 times the power of -1 plus 1 raised to the power of 1/3, not 1/23, is -1. So those are the real solutions. And now just back to some factoring practice, okay? So remember, for factoring, we're using the rule of zeros, the zero principle. If A times B is 0, then A is 0 or B is 0. Couldn't even see that, sorry. So we're just going to factor what we can. Here we have x squared equals 9x, sorry, x to the 4th equals 9x squared. What you need to do first when you're factoring is put it into standard form. So x to the 4th is positive, and it's our greatest highest exponent. So I'm going to move the 9x squared over. And what I'm left with is x to the 4th minus 9x squared equals 0. Good? All right, here I can factor out an x squared. Can I not? X to the 4th divided by x squared is x squared. And then -9x squared divided by x squared is a -9 equals 0. Good. I'm going to move it on down here. So my two terms now are x squared is 0 and x squared minus 9 is 0. Good. So as soon as I've factored it, I can set each factor equal to 0 and try to solve each one for x. Okay. How do we solve something x squared for x? We just take the square root and make sure to plus or minus the other side. So the square root of x squared leaves us with x. Positive square root of 0 is 0. Negative square root of 0 is also 0. So x is 0. On the other side, we have x squared minus 9. So here we have x squared equals 0. So we were immediately able to take the square root of x squared. Here we want to isolate the x squared before you take the square root of it, okay? So I'm going to add 9 on this side, add 9 on this side. I'm left with x squared equals a positive 9. To solve for the x squared, take the square root. Good? The square root of x squared just leaves me with x. equals plus or minus the square root of 9 is 3. So my three answers are x is negative 3, x is 0, and x is positive 3. Okay, there were no radicals, so I don't need to check. I mean, you should check your answer, but there are not going to be any extraneous answers. Those are all 3 valid answers. So for this question, x is negative 3, 0, and positive 3. Good? Okay, this next one, x cubed plus 4x squared minus x minus 4 is equal to 0. All right, what I would do for this one is factor by grouping. X cubed plus 4x squared minus x minus 4 is 0. It's in standard form. Over here, over here, once we put it into standard form, I could see that both the x to the fourth and the negative 9x squared, you could factor out an x squared. Here, I can't factor anything out of all 4, so I'm going to factor by grouping. My first 2 terms are x cubed plus 4x squared. I can factor out an x squared, right? So that means I have x squared. X cubed divided by x squared is x. 4x squared divided by x squared is 4. Good. On this side, I have a negative x minus 4. I can factor out a negative nothing, right? There's no common factor between x and 4, or negative x and negative 4, so I'm just going to factor out a negative 1. Negative x divided by negative 1 becomes x. Negative 4 divided by negative 1 becomes positive 4. After that, I realize that I still have that binomial that is common to both of them, so perfectly reasonable to use that. Factor it out. X plus 4 times x squared minus 1. Okay, just because you factored out a 1 doesn't mean it's wrong, because it would only be wrong if these two weren't the same. You want these two to be the same so you can factor them out and leave the last 2 factors as your other binomial. Now remember, you have one more step. X plus 4 is 0. Subtract 4. X is negative 4. Here, x squared is minus negative 1 is 0. Add 1. X squared is 1. Take the square root. And we get x is negative 1 and 1. So my 3 answers here are x equals negative 4, negative 1, and positive 1. Good? All right. Next example is x minus 4 quantity squared plus 3 times x minus 4 minus 18. So here I would just solve it by combining like terms. So you're going to distribute the 3. You're going to change the x minus 4 squared into a trinomial. So that'll be x minus 4 times x minus 4 plus 3 times x, right, is 3x. 3 times a negative 4 is a negative 12, minus 18 is 0. Here, x minus 4 times x minus 4 becomes x squared minus 4x minus 4x plus 16 plus 3x, and then negative 12 minus 18, what is that? Negative 30, right? Equals 0. I can now combine x squared negative 4 minus 4 is a negative 8 plus 3x means a negative 5x plus 16 minus 30. So negative 30 plus 16 is negative 14 equals 0. Good. Now you've just got your regular trinomial. So it needs to multiply to negative 14 and it needs to add to negative 5. You could do 1 and negative 14. You could do 2 and negative 7. And that one, sorry, that one will work, right? So it becomes x plus 2, x minus 7 equals 0. Do not forget, this is different than the review unit. Do not forget that now we solve for x. So x plus 2 is 0. X minus 7 is 0. X is negative 2. X is 7. Good? So this guy was x is negative 2 and 7. This one was x is negative 4, negative 1, and 1. This next one's interesting. This one is x to the 4th minus 26x squared plus 25 equals 0. Here, there's nothing we can factor out. There aren't 4 terms to factor by grouping. It sounds very different from what we've been doing before, but what I want you to do is I want you to replace the x squared with a new variable. So the x squared is going to be a u, and because x squared is x to the 4th, x to the 4th is u squared. Okay? So x to the 4th becomes u squared minus 26. We said x squared is u, right? Minus 26u plus 25 is 0. I know it feels like that came out of nowhere, but that is the tool we're going to use to make this factorable, because I can't factor x to the 4th minus 26x squared plus 25 equals 0. But if I replace all my x squareds with u, meaning that x to the 4th becomes u squared and x squared becomes u, now I have something factorable, believe it or not, right? Because what I have is u my a is 1, b is negative 26, and c is 25. So I need something that multiplies to equal 25. This is exactly what we used to do, right? And adds to equal negative 26. So it's, again, something you're now familiar with. It's not an x, but besides the variable being a u and seeing what was above it, we know what to do, right? Multiplies to 25, adds to negative 26. It's going to be negative 25 and negative 1, right? If I add those together, I get negative 26. If I multiply them, I get positive 25. So u minus 25, u minus 1. Okay? Now, u minus 25 is 0. So u is 25. U minus 1 is 0. U is 1. You're not done yet. This isn't the answer because u is x squared and we're solving for x. X squared is 25. X is negative 5 and 5. X squared is 1. X is negative 1 and 1. So my 4 answers are x is negative 5, negative 1, 1, and 5. Right? Let's do one more of those, shall we? So this one was x is negative 5, negative 1, 1, positive 5. Our last example will be 5x to the 4th plus 7x squared minus 6 is 0, right? I have x to the 4th and x squared. U is x squared. So instead of 7x squared, I'm just going to have 7u. Good. X to the 4th is u squared, because x squared squared is x to the 4th So u squared is x to the fourth. So we have 5u squared plus 7u minus 6 equals 0. We're going to want to factor that into some u's, right? Or you're welcome to put it into the quadratic formula. We're just trying to solve for u, and then we will go back and replace u with x and solve for x. So we want a term that multiplies to equal negative 30, right? Because positive 5 times negative 6 is negative 30, and that adds to equal 7. So we have negative 1 and 30. We have negative 2 and 15. We have negative 3 and 10. Yeah. Yeah, so it's negative 3 and 10. 10 minus 3 is 7. So what I'm going to have is 5u squared plus 10u minus 3u minus 6 equals 0. What can I factor out of 5u plus 10, 5u squared plus 10u? I can factor out a 5u. I get 5u times, 5u squared divided by 5u is just u. 10u divided by 5u is 2. Negative 3u plus negative 3u minus 6, divide both by 3. By negative 3, because if this is a negative, you need to keep that a minus. So minus 3. Negative 3u divided by negative 3 is a positive u. Negative 6 divided by negative 3 is a positive 2. So now I have the common u plus 2 being multiplied by 5u minus 3 is equal to 0. Good? That means u plus 2 is 0. U is 2. 5u minus 3 is 0. 5u is 3. U is 3/5. But we're not solving for u, we're solving for x. So u becomes x squared. X squared is equal to 2. So x is going to be the positive and negative square root of 2. X squared is 3/5. So x is going to be the positive and negative square root of 3/5. So for this last one, our answers are going to be x is negative square root of 2, negative square root of 3/5, square root of 3/5, and square root of 2. Good. All right, and that is 1.4. Thank you guys, and email me with questions.